There is no national electrical code requirement to have an outlet installed across from the dryer outlet specifically for an iron. Electrical installations must comply with the National Electrical Code, which is a comprehensive set of standards for safe electrical design, installation, and inspection. The code addresses numerous aspects of electrical systems but does not mandate a convenience receptacle near a dryer outlet for the purpose of operating an iron. The purpose of the National Electrical Code is to safeguard persons and property from hazards arising from the use of electricity. It achieves this through detailed regulations covering wiring methods, overcurrent protection, grounding, and equipment installation. Each edition of the National Electrical Code is updated every 3 years to incorporate new technologies and address emerging safety concerns. It is essential for electricians, inspectors, and engineers to stay current with the latest edition. While the National Electrical Code does not require a specific outlet for an iron near the dryer, general requirements for receptacle placement in dwelling units may apply. These requirements ensure that receptacles are conveniently located for general use. According to the National Electrical Code, receptacle outlet should be installed so that no point along the floor line in any wall space is more than 6 feet measured horizontally from an outlet in that space. This rule ensures that extension cords are not used excessively, which can pose a safety hazard. In laundry areas, the National Electrical Code typically requires at least one receptacle outlet for general use. This receptacle can be used for various purposes, including powering an iron, but it is not specifically mandated for that purpose. The specific requirements for receptacle placement can be found in Article 210 of the National Electrical Code, which covers branch circuits. Branch circuits are the circuits that extend from the final overcurrent device protecting the circuit to the outlets. There are several types of branch circuits, each designed for specific uses and ampacities. For example, a 15-amp branch circuit can supply lighting and general use receptacles, while a 20-amp branch circuit is often used in kitchens and laundry areas. When installing receptacles, it is important to adhere to the National Electrical Code guidelines for wiring methods. The National Electrical Code specifies approved wiring methods for different types of installations, including rigid metal conduit, electrical metallic tubing, non-metallic conduit, and cable assemblies. Each wiring method has specific requirements for support, protection, and grounding. Grounding is a critical aspect of electrical safety, as it provides a low-impedance path for fault current to return to the source, tripping the overcurrent device and preventing electrical shock. The National Electrical Code requires that all metal enclosures and equipment be grounded, either through a direct connection to a grounding electrode system or through the use of equipment grounding conductors. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. Overcurrent protection is another essential aspect of electrical safety. Overcurrent devices, such as circuit breakers and fuses, are designed to protect circuits from excessive current, which can cause overheating and fires. The National Electrical Code specifies the maximum allowable overcurrent protection for different types of conductors and equipment. It is crucial to select the correct size overcurrent device to ensure adequate protection without causing nuisance tripping. In addition to receptacle placement and wiring methods, the National Electrical Code also addresses other important aspects of electrical installations such as lighting, appliance circuits, and special equipment. Lighting circuits must comply with energy efficiency standards and provide adequate illumination for the intended use. Appliance circuits, such as those for refrigerators and ranges, must be sized appropriately for the appliance load. Special equipment, such as swimming pools and spas, have specific requirements to address the unique electrical hazards associated with these installations. Electrical inspections are an important part of ensuring compliance with the National Electrical Code. Electrical inspectors review electrical installations to verify that they meet the requirements of the code. They may identify violations and require corrections to ensure safety. It is important for electricians and contractors to cooperate with electrical inspectors and address any concerns promptly. When planning an electrical installation, It is always best to consult the latest edition of the National Electrical Code and seek guidance from qualified professionals. The National Electrical Code is a complex document, and it can be challenging to interpret and apply its requirements correctly. Consulting with a licensed electrician or electrical engineer can help ensure that the installation is safe and compliant. In summary, while there is no specific National Electrical Code requirement to install an outlet across from a dryer outlet for an iron, general receptacle placement requirements may apply. It is essential to adhere to all applicable National Electrical Code requirements to ensure safe and compliant electrical installation. Always consult the latest edition of the National Electrical Code and seek guidance from qualified professionals when planning an electrical installation. The National Electrical Code, or National Fire Protection Association 70, is a regionally adoptable standard for the safe installation of electrical wiring and equipment in the United States. It is part of the National Fire Code series published by the National Fire Protection Association, or NFPA. While the National Electrical Code is not itself a law, it is adopted by states and local jurisdictions in order to standardize their enforcement of safe electrical practices. In some cases, the National Electrical Code is amended with local changes. The National Electrical Code is updated and published every 3 years. The official name is National Fire Protection Association 70 National Electrical Code. The scope of the National Electrical Code is to cover the installation of electrical conductors and equipment within or on public and private buildings or other structures, including mobile homes, recreational vehicles, and floating buildings, and other premises such as yards, carnivals, parking lots, and industrial substations. The National Electrical Code also covers the installation of optical fiber cable and equipment. The National Electrical Code does not cover the installation of electrical conductors and equipment in ships, watercraft other than floating buildings, railway rolling stock, aircraft, or automotive vehicles, nor does it cover the installation of communication equipment under the exclusive control of communication utilities. The National Electrical Code is organized into chapters, articles, and sections. Chapter 1 contains general information such as the purpose and scope of the National Electrical Code, definitions, and rules for administration and enforcement. Chapters 2, 3, and 4 contain requirements for wiring and protection, wiring methods and materials, and equipment for general use, respectively. Chapters 5, 6, and 7 contain requirements for special occupancies, special equipment, and special conditions, respectively. Chapter 8 covers communications systems. Chapter 9 contains tables and examples. The articles in the National Electrical Code are numbered sequentially within each chapter. For example, Article 210 covers branch circuits. The sections within each article are also numbered sequentially. For example, Section 210.52 covers receptacle outlets and dwelling units. The National Electrical Code uses a system of abbreviations and symbols to represent electrical terms and concepts. For example, volts is abbreviated as volts, amps is abbreviated as amps, and ohms is abbreviated as ohms. The National Electrical Code also uses symbols to represent electrical components such as resistors, capacitors, and inductors. The National Electrical Code is a complex and comprehensive document, and it is essential for electricians, inspectors, and engineers to have a thorough understanding of its requirements. There are many resources available to help people learn about the National Electrical Code, including textbooks, training courses, and online resources. The National Fire Protection Association also offers a variety of publications and services related to the National Electrical Code. It is important to know that the National Electrical Code is not a design guide. It provides minimum requirements for safe electrical installations, but it does not provide guidance on how to design an electrical system. Electrical design is a complex process that requires specialized knowledge and experience. It is always best to consult with a qualified electrical engineer when designing an electrical system. When working with electricity, it is important to follow all safety precautions. Electricity can be dangerous, and it is essential to take steps to protect yourself from electrical shock. Always turn off the power before working on electrical circuits. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician. The National Electrical Code is a valuable resource for ensuring safe electrical installations. By following the requirements of the National Electrical Code, you can help protect yourself and others from electrical hazards. Remember to always consult the latest edition of the National Electrical Code and seek guidance from qualified professionals when planning an electrical installation. Ensure that all electrical work complies with local codes and regulations which may have additional requirements beyond the National Electrical Code. Electrical safety is paramount, and adherence to these codes is crucial for preventing accidents and ensuring the well-being of individuals and property. Always prioritize safety when working with electricity and seek professional assistance when needed. There are several key areas within the National Electrical Code that address specific requirements for different types of electrical installations. One such area is Article 250, which covers grounding and bonding. Grounding is the process of connecting electrical circuits and equipment to the earth, providing a path for fault current to flow back to the source. Bonding is the process of connecting different metal parts of an electrical system together to create a low impedance path for fault current. Article 300 covers wiring methods, which include the types of wiring that are permitted in different locations and under different conditions. Wiring methods include rigid metal conduit, electrical metallic tubing, non-metallic conduit, and cable assemblies. Article 310 covers conductors for general wiring, including the types of conductors that are permitted for different applications and the ampacity of conductors. Ampacity is the maximum current that a conductor can carry continuously without exceeding its temperature rating. Article 400 covers flexible cords and cables, which are used to connect portable appliances and equipment to electrical outlets. Flexible cords and cables must be protected from physical damage and must not be used as a substitute for permanent wire. Article 430 covers motors, motor circuits, and controllers, including the requirements for motor overcurrent protection, motor disconnecting means, and motor control circuits. Article 440 covers air conditioning and refrigeration equipment, including the requirements for disconnecting means, branch circuit protection, and motor compressor overcurrent protection. Article 500 through Article 516 cover hazardous locations, which are locations where flammable gases, vapors, liquids, or dusts are present. Hazardous locations require special wiring methods and equipment to prevent explosions and fires. Article 600 covers electric signs and outline lighting, including the requirements for sign circuits, sign wiring, and sign grounding. Article 680 covers swimming pools, fountains, and similar installations, including the requirements for bonding, grounding, and ground fault circuit interrupters. Ground fault circuit interrupters, or GFCIs, are devices that protect people from electrical shock by detecting small amounts of current leakage to ground and interrupting the circuit. The National Electrical Code also includes tables that provide information on conductor ampacity, conduit fill, and other electrical parameters. These tables are essential for designing and installing electrical systems that comply with the National Electrical Code. In addition to the National Electrical Code, there are other standards and codes that may apply to electrical installations. These include the National Electrical Safety Code, or NESC, which covers electrical power and communication lines, the International Building Code, or IBC, which covers building construction, and the International Residential Code, or IRC, which covers residential construction. The National Electrical Code is a living document that is constantly being updated to reflect changes in technology and safety practices. It is important to stay current with the latest edition of the National Electrical Code to ensure that electrical installations are safe and compliant. The National Electrical Code is an essential resource for anyone involved in the design, installation, or inspection of electrical systems. By following the requirements of the National Electrical Code, we can help protect people and property from electrical hazards.